Okay, so this is still pre-lecture task 1, and this time around what I'm going to be doing is having a look at this particular pair here. Now for this I'm going to attempt to use some real models to look at this, and what I want you to notice is that the ring is puckered down here and that the ring is puckered down here. So again, we're going to take the perspective of where these axial chlorines are. And so this is what I'd like to show you. I'm going to swap over to the camera, and here we have on the left hand side, okay, that axial chlorine is pointing down, and then here we have that equatorial chlorine pointing down. So this corresponds to the left hand molecule, i.e. this one here. And then what I'm going to do is I'm now going to show you the right hand molecule. So here we have the right hand molecule where the axial chlorine is pointing down and the carbon towards the back pointing towards the wall. That's this one here. That's also equatorial down. Now all I'm going to do here is I'm going to take this model on the right hand side, okay, and I'm going to rotate it around 180 degrees. So I've now rotated it round 180 degrees, and I'm hoping what you can observe here is that it has exactly the same connectivity. So you're looking at exactly the same molecule. So therefore these are identical to one another. Okay, so now that we've established that these are identical, they're the same, or we could say they are non-isomeric, the next thing to do is to look at the stereocenters of this center and this center. So I don't need to do the same thing here because it is exactly the same molecule. What I do need to do, however, is to put on the hydrogens and think about their relative stereochemistry. So that would be axial up, whereas this hydrogen here would also be equatorial up. Now if I go ahead and draw that out and I take this perspective here, then we're saying that the chlorine is at the bottom like this, and we went in a clockwise fashion, so therefore this chlorine is also going to be pointed down. Now if you remember, that must mean that these hydrogens, they are on a up or a solid wedge. So we've got to be careful here, because whatever stereochemistry we give these centers, we're going to need to remember to flip it at the end. So the first thing is to assign the priority. So I'm going to start with this carbon here. This obviously is priority D. This here is priority A. Now if I trace around to the right hand side, I'm going to encounter a carbon that was here, a chlorine that is here, and also the hydrogen that is attached to there. Now if I go round to the left hand side of this carbon, I'm only going to see a carbon, which is here, a hydrogen and a hydrogen. So therefore it's fair to say that the right hand side of the molecule is going to be B in terms of this side here, and then this side here is going to be C. So when I trace it round, okay, so I'm tracing this round, now it appears to be going in an anti-clockwise direction. Appears to be going in an anti-clockwise direction, so we would imagine it to be S, but as you all know, that is in fact going to be R. With respect to the other stereocenter, just for the sake of clarity, I'm going to clear off these, and then I'm going to treat that one as well. So, by the way, the bottom carbon, the one that's currently marked in red, that would be carbon number 1. So I'm going to just change the pen now to, actually I'll keep a purple pen for this. So therefore this is going to be A, this is going to be D, this is going to be B, this is going to be C. So again, if I now rotate it around, it will go in a clockwise direction, A, B, C. So that would appear to be R, but of course the H is on a solid wedge, so we know to reverse. So therefore we have here the name of this would be 1. So the name of this would be 1R 2S, which goes in brackets, and this is 1 2 again, because we still need to say that these are the locants. 1 2 dichlorocyclohexane.